So, hello, good day, welcome. My name's Chris Taylor. I am a security consultant. I run a company called Tuxati Consulting. I specialize in locking down media and entertainment companies. I did about 20 years worth of work in other industries and eventually decided this was a niche that needed somebody to focus on it. So that's all my company does is media companies now, VFX studios, companies of that nature. And what we do is, lock down those workflows. And I'm decent on Linux. You guys know it way better than I do. So I'm not going to get into a lot of technical details on the implementation on some of the bullets that I'm going to talk about, because you can probably come up with 5 different ways to do a thing that I put up a bullet about. So how we implement some of the security features I'm going to talk about, I will leave to you, but we'll try to get them in there. It's all going back to various security frameworks that you're going to have to be compliant with. Eric touched on several of them as he was talking about TexCare's various products. There's a lot of security frameworks that you can choose from. There's easily about 30 out there in the industry. The 3 that are most important to your world, ISO framework, ISO 27000 is an international standard. Unfortunately, it is stuck behind a paywall, which does limit a lot of people's ability to get to it and implement it. But if you're an international company, it's a good one to look at. NIST has a wonderful framework, the cybersecurity framework, the CSF, or the catalog of controls that drives the NIST framework is SP 800-53. And good thing about NIST framework, even though it was designed by and for the US federal government, it's a really easy to read and it's free. So it's broadly usable across any industry. It's not really government focused. And that one's very popular just because it's free, it's easy to read, it's easy to implement. And then the third one that is specific to media companies in the world comes from the Motion Picture Association. They also run a completely owned subsidiary under the MPA called the Trusted Partner Network. And they do assessments against media companies with their own security framework that is called the Content Security Best Practices. And for each one of those 3 presents you a complete security framework for your entire company, and it's an entire catalog of everything you need to do. There's one fourth one that I'm going to bring up is the Center for Internet Security. They don't publish an entire framework for everything. What they publish is a top 18 list. These are the 18 most important things you should do. Every couple of years, they host a poll, and they ask a couple of thousand people all over the world, my peers that work cybersecurity, all they do all day long is cybersecurity work. They will answer this poll and come back with, these are the things that are giving us the most return on investment, so these are the things you should focus on first. And the CIS Top 18 list then gives you a prioritized list. Number 1 on the list is the thing you should do first. Number 2 on the list is the thing you should do second. And that gives you a direction to go. So when you open up something like ISO 27000 and you see 174 controls, where do I start? The CIS list gives you a place to start. It's not going to go through all of the 100 controls that are in one of the other frameworks, but it at least gives you a good place where I know if I do this, I'm going to get the most movement on my security posture measuring needles. All right. So one of the problems with these control frameworks is that they are huge. You don't want to just go sit at the beach and read one. People will kick sand on you. So you treat it like it's an encyclopedia. You use the index, you use the table of contents, the Control F button. You find the particular topic you want to know about. You skim through it, pretend you're an expert afterwards. But you shouldn't just try and sit down and read one of these. You'll fall asleep. They're also pretty darn large. There's 322 controls inside of the NIST framework. It's overwhelming. So that's why the CIS list is so important to us, because it can kind of give us an order of where we should go with it all. And for every one of those controls, there's multiple right answers for how do I implement that control. So depending on each environment being slightly different, the requirements being different, the risk posture for the company being slightly different, we'll have to adjust exactly what we're looking at for each one of them. All right. So what I'm going to walk through here is a a subset of the CIS top 18 list that focuses specifically on what you can do to a workstation to lock it down before you hand it to a user. So if you're issuing laptops out to artists or to developers and you need to be able to secure it so that they can work on it without having to worry about malware showing up, this is the things we would do to lock that down. And I'm primarily focused on workstations as I talk through some of these controls, because I'm most worried about what are your end users, especially the less technical animator types, that they're more likely to go to the seedier parts of the internet and download malware. So how do we lock down that workstation that'll limit the malware's ability to do anything bad with it? Now, with that intro out of the way, to set up where we're going, I've got about 5 hours worth of content packed into these slides and 20 minutes left. So I am going to go through these pretty quick and at a very high level. If you have questions about them afterwards, just go find Eric and ask him. Where'd he go? He's not here. It's more fun to make fun of him if he's still here. He's not here. Damn it, he abandoned me. All right, so the first one on the list, I'm skipping down to CIS control number 3. 1 and 2 are about having an inventory across your entire, that's more of a big program problem, not a specific workstation problem. So we skip down to number 3, data protections. How do you protect the sensitive data on an individual workstation? And the first one is to turn on your access controls. We'll go into more detail on access controls in a little bit, but it starts with setting up the ownership and permissions on specific, especially critical files, and getting those things locked down so that if there's 2 or 3 users using the same workstation, user A shouldn't be able to see user B's files, etc. Right. Next, we got to work on encryption at rest. If it's a laptop that's going to leave the building, anything that's portable and has the potential to walk out of a building, do encryption at rest across that entire hard drive. Servers that are racked into a data center, you can be a little more lax about that, but it's, if it's going to leave your building, you want to have some kind of a whole disk encryption across the entire thing. Now, even with the servers, there's certain workflows where you're going to have to do encryption at rest across a workflow. If I need to be able to set up a proxy and move a file from a render farm out to a delivery somewhere else, then I'm going to have some kind of a file transfer process in place that we get that file back and forth. And the MPA controls are going to require you to have encryption at rest as that file moves through your environment. So encrypt that individual file as it moves, or encrypt the folder where it lands, and then it picks up the encryption by default by being inside that folder. Some of the ways you can do that is, when you do a tar-gz on a file, just add 1 additional pipe and run it through OpenSSL or GPG is an easy way to add encryption to individual files. A lot of people love to take the sensitive file they're about to email to somebody and just put it inside of a zip and add a password to it. That takes me about 30 seconds to crack that. Zip has absolutely horrible security. So if you're putting sensitive files inside of a zip to email them to people, don't put it in a zip. Put it in a RAR or 7-zip, something of that nature. It uses much better key handling and better security. Right. For doing an entire disk or at least a whole folder, instead of piping it through an individual file, you can use something like Lux or CryptoFX. You create a separate partition, you map the user's folder or a data folder or whatever it is off to that separate partition, and then you can lock down the entire file system in that folder, and that gives you an entire folder or partition being encrypted at rest. Data classification scares a lot of people. It sounds like a really big program where you're going to have an entire team people go through and try and tag files and keep track of it, lots of technical controls. It's a burden for a big company like Disney and Warner Brothers to pull off. So how is a small company going to do it? The simple answer is don't. You create the categories of your what your sensitive data is, and you create rules for if it's this type of data, it should handle it this way. If it's a different category of data, handle it a different way. And then you just put the onus on training your employees what those categories are and what the rules are, and you put the onus on the individual people, and you don't have technical controls in place. Okay. That way, when it comes time for a TPN auditor to come in and look at your environment, or if you're going through an ISO auditor, et cetera, you can still claim you have a data classification program. You just don't have the technical controls to enforce it. You've still checked the box, though. All right. Next, moving into the securing the configuration of the individual workstation. That's CIS control number 4. I should have mentioned the index box down at the bottom there earlier. I'm putting up 4 or 5 bullets on each one of these slides. Something I say on that slide maps to one of those control items for each of the control frameworks you're dealing with. So when it comes to securing the configuration of the base OS, if you're trying to map this back to the MPA content security best practices, it's one of those 5 controls or what we're about to talk about. Right. Primary thing you're looking for is to limit your attack surface on a workstation or a server by removing unused software. Take out Telnet, or take out things like rlogon and FTP. Only use the secure alternatives. So you'll still have SSH, you'll still have SFTP or some other type of file, SCP or other type of file transfer protocol that's actually secured. You just get rid of the binaries completely so they're not even on the box. That way they don't accidentally get called. There's any kind of a file system modules that aren't in use, just remove them from the machine. If a bad guy steals one of your user's passwords and logs into that workstation, you want them to have as few tools that they can use to install their malware and do bad things to your network with. So if you take those libraries away, they'll try to install some kind of a malicious toolkit and it won't install correctly because the libraries it's trying to call aren't there. Same thing with GCC make tools, any kind of build tools that you would use. If the user doesn't need them on the box, take them off. All right? If you need them to build software to install, do that on a build system back in your IT workstation somewhere, and then package up the tool and put it on the user's workstation rather than building it locally on that user's workstation. Again, this falls back to when a bad guy gets on that workstation and starts doing something because the user clicked on a phishing link, you don't want them to have the tools necessary for their malware to install. I broke it. It's not going to the next slide anymore. Excellent. Am I going to have to drive from the keyboard? I can. Don't think I won't. Yeah, cool. We didn't want to do that anyway, right? Which one of these is? No, the screen changed to a different app. It wasn't on PowerPoint anymore. All right, so back to where we were. My apologies. All right, next thing you want to do is prevent the end users from making any modifications to the whole workstation. Now, on a server, you're generally only going to have admins logging into the base OS on a server, so it doesn't really apply as much in that environment. But if you're handing out AlmaLinux workstations to your artists and developers, you don't want them to make modifications to the whole OS, only to their individual environment. So lock down the bootloader, require a password to do any modification to the boot process, lock down a BIOS password. That way, if the laptop gets stolen, somebody won't be able to bypass the operating system's controls, change the boot order, and boot off of a different operating system, et cetera. If you can limit the user's ability to change things at the operating system level, some of the configurations there, just one as an example, you don't want them to change what their DNS settings are. So if I'm forcing that workstation to use my DNS server so that I can apply filtering to what domains they resolve, I don't want them to just go change that setting and start using Google's 8888. All right, so that'll bypass one of my security products. So if we just make sure all those boxes are locked down so that the user can't get to them. In a minute, when we talk about locking down local admin control, if the user has local admin, they can bypass that and go start making those modifications to the base OS config, and I don't want them to. So we'll come back to talking about that as we talk about locking local permissions down, but that's one of the reasons why we don't want them to have local admin. They'll make changes to the system, and those will open up vulnerabilities for you. And anytime you have lots of workstations that are out there, you're not going to want to have your desktop support people administering them one at a time. It's really, really slow. It's a lot of pain. So you want to automate that remote management as much as you can so that if I need to come in the middle of a malware outbreak and say, I need you to go apply this change to these 500 compromised workstations, I don't want to sit there and watch them SSH into each one individually and install a piece of software. The malware will stay ahead of us forever if we do that. So automate that remote management so that you can be as fast as possible to make changes to that entire environment. When it comes to individual user accounts and handing out user accounts to your entire org, as much as you can, try to centralize that to some kind of a directory. That gives me two benefits. If they're authenticating off of a central directory, every time they log in off of that system, I get a log off of the central directory that says this user just logged in on this asset. And that allows me to do auditing of what are all the authentication events in my environment. If the authentication event is only happening locally on that workstation, it's much harder for me to push those logs into the central log collection server somewhere. Second advantage is when I terminate an employee, I shut off their account in one spot and they lose access to the workstation. If the accounts are local on all of those workstations, when I try to terminate that employee, I then have to go log in all those places and terminate that account and lock it down. So you want centralized account management as much as you can so that we can have better logging and we can lock people out as quickly as possible if there's a problem with their account. And you want to restrict local admin privileges as much as you can. This is a pretty big one because it will limit the blast radius of malware. If that user clicks on a phishing link and the malware starts trying to do something, you're forcing the malware to execute as a local user instead of as an admin, and the malware won't be able to do as much damage to that workstation. So this one's really important for user land. Keep the local admin privileges pulled away. Now, if you do have a developer who needs to have local admin for whatever particular reasons, create a second account for them that has those permissions, and then make them log in as a user, browse the internet as a user, check their email as a user, and then when it's time for them to do some kind of an admin task, instead of doing sudo and typing in that same user account's password that's already been compromised when they clicked the phishing link, you force them to sudo as a completely different user and supply a different password. They have to jump through one extra hoop, but you've also isolated the malware from being able to jump that hoop. Because if the malware's in there executing as their user account, it can sue up into those elevated privileges. But if the malware tries to jump and it hits a second login prompt for a different user account, it usually halts that piece of malware from getting into its next step. Right. Enforce strong passwords is really good. The password recommendations across the security industry have changed over time. It used to be that we were telling people to pick really strong passwords and then change them every 90 days. And the logic behind that was if the password was ever stolen, the hash of that password was stolen, and the bad guys are running password cracking software to figure out what it was, it would take them more than 90 days to crack the password, and then they would come back into the environment 92 days later, and the password wouldn't work because you just changed it. The problem that we ran into, much like the Wi-Fi password in this building, you end up with people who pick really, really bad passwords, and if their password is password 2, I know it's going to be password 3 in another 90 days, right? So instead, what the security industry has shifted away from is pick really strong passwords and then only change them if there's some kind of indication that there's been a compromise. Now, the way for that to work, you have to also get rid of password reuse. Because if you're using the same password for your LinkedIn account that you're using for your work accounts, and LinkedIn has a breach, and now all of those LinkedIn passwords are out available for sale on the dark web, I can go buy those, and then I'll start just dropping in all of those passwords into your work accounts just to see if they work. An example of how that works, y'all heard of Disney Plus? It's a streaming service. You may or may not have heard of them. They host a couple of Pixar movies. There's nothing else in there you want to watch. All right, and no Disney people to make fun of? Okay. So the Disney launched that service in November of 2019. I think it was in November 19th, 2019, if I remember rightly, was the launch date. They had a coming soon page up for months before that, and there were there was like a little welcome page where you could sign up for an account. But on the launch date, the whole website changed, and now there was an actual login prompt, and you could log into your account and start actually watching TV shows. And when they flipped the switch and the site went live, 3 hours later, we were pulling credentials up for sale on the dark web. It took the attackers 3 hours to crack into Disney Plus and then offer working username and password combinations up for sale. Now, you spend $150 buying your Disney Plus login. I spend $25 buying it off the dark web, and I'm logged in as you. You get in trouble for password sharing, and your account gets shut down. You spend another $150 to get a second account to repair yourself. I buy a second password for $25. I'm still well ahead in this game. All right. Now, the way the attackers were able to pivot that in under 3 hours, password reuse. Your accounts were getting compromised over on Yahoo and Google and LinkedIn and Facebook, and all these other accounts were getting compromised, and they had an email address to use a password combination from all these other data breaches, and they just started stuffing them into the login prompts one after another to see which ones of those passwords worked. And it works regularly. We call it password stuffing in the security industry. Right? So the way you get around this is you have to educate your users. Don't reuse passwords. Pick really strong passwords. Use a password manager, and it will keep all your passwords unique and strong. Right? If you want to enforce complex passwords on your Linux workstations, there are ways to do it. Just edit these the files in the pam.d folder, and you can set complexity requirements, etc. Right? And then periodically go back and audit your accounts to make sure there's, those things are actually enforced. When it comes to access controls, again, you're going to set permissions in your centralized directory. That way, if the user moves from one department to another department, I can make those changes in one spot, and they lose permission to this server and gain permission to that server, and I don't have to worry about any kind of access creep over time. Right? On your individual workstations and servers, there's various levels of access control that you'll want to implement in that operating system. One is to tune the SE Linux policies. AlmaLinux has SE Linux turned on by default, so you're just make sure it wasn't turned off for some reason. But then you should also do some tuning to the policies to make sure it actually matches your environment and works correctly. And then you want to go into the access controls for the, make sure the ownership of files and the permissions on files are all set correctly. And then you'll be able to enforce the role-based access controls. You can use the set facle to start creating access controls for whole files and folders, and that'll help lock people down in there. All right. And when it comes to individuals onboarding and offboarding as they terminate or as they move to another team, you should have, as an admin, a whole checklist style process for that. That way no steps get missed. If I've got 4 people as desktop admins, I want all 4 of them to do the exact same steps the same way every time. That way nothing gets missed and we don't accidentally leave them access on this server and then they come back as a disgruntled fired employee 2 months later and end up changing menus at a theme park or something silly like that. Not that that would ever happen. Yeah, it happened. So that's if we have that checklist style offboarding, we don't want to miss anything and leave them access. And anytime you have external, remote, or very sensitive access, enforce multi-factor authentication. Microsoft did a study on this a while back and found that in all of the account takeover type attacks, had multi-factor been on, it would have thwarted 99.9% of those incidents. So turn this on. It makes a huge difference in keeping people out of your sensitive data, or keeps the bad guys out of your sensitive data. And then periodically go back and audit. Make sure, this team that's working on this project comprised of these 8 people, are these still the correct 8 people? Oh no, that guy moved to this other team, then you need to remove them from that group so they don't have access to that server anymore. From vulnerability management, this when you go read the security frameworks, they're usually talking about setting up a vulnerability scanner and scanning your entire environment. There's some things you need to do to your workstations in order to make that work properly. Your vulnerability scanner should be authenticating into devices when it finds them. So there's going to have to be a service account, and you're going to have to change some of the permissions for that service account to make sure it can actually log in and get to all the configs. So as part of your gold disk image that you're creating all those workstations off of, make sure that service account is configured to be allowed to log in. If the vulnerability product that you're using has a agent, have that pre-installed ahead of time. This is wonderful for this modern world where remote employees are constantly leaving the building and working from coffee shops. The vulnerability scanner isn't going to see them. So an agent-based collection of that data will allow you to get that same data even if the employee is working from home and never comes into the office. Right. And make sure your OS patches and your various application patches are all installed everywhere. This is a very, very huge. This is probably one of the #1 ways that you can keep malware and attackers out of your environment, is just having all your patches installed regularly. Your logs need to be pushed to some kind of a central logging system. If you're logging only on the individual workstation, there's a lot of things happening there that your security team will never know about. If you can get the logs off of all of your devices put to one central place, it makes it a lot easier for us to keep track of all of it. In order for centralized logging to work, you do have to have everybody on the same clock, so make sure you got a good NTP environment going on in your place. And if you're on individual workstations and servers, tune Audit D on those workstations, and Audit D can start collecting things like file accesses and local authentications, and there's about 5 or 6 different categories of data that Audit D can collect, and then it just adds log entries into your syslog stream, and you push those off to your central log aggregator wherever it is. All right. Don't forget about all the applications. A lot of them don't log to your main syslog that your OS is logging to. So certain applications that are on your environment, if they're collecting logs, create some mechanism for pulling those logs into your central log aggregator as well. If you have an EDR product that you're deploying on those workstations, then it can grab a lot of extra data that none of the normal logging things can grab. That's a lot of wonderful telemetry involved in that. On a server, you shouldn't even have an email client or a web browser. Just nix them right off of there. If you need to be able to go out on the internet to download a patch or some kind of an update, do that from your own workstation and then push it onto the server. Don't just open up a browser on a server. This is one of the #1 causes of malware on servers, is I see browsing activity leading to a background download that they didn't realize was happening while they were downloading something else. Now, to protect that email client and browser on a workstation, one of the things you can set up is DNS filtering. This is a wonderful security control. If you're, usually when we do DNS filtering, it happens at your DNS resolver. We do it at the network infrastructure level, but you can also do it on the individual workstation. That way, when that laptop goes home, we can still be filtering there by updating the etc host file and start listing all of the known malicious websites on the internet and route them to a black hole IP address so that their traffic doesn't go out. User clicks on a phishing link, it tries to resolve evil.com and just gets sent to the bit bucket instead of going out to the internet. Is a great way with no money spent. Now, the only problem is you have to constantly update the host file with a list of here's the new domains that we know about as of today. You can also use URL filtering if you've got a web proxy or a Pi-hole, something like that at the network level. That's a great way to protect an entire network's worth of traffic. On the individual workstation, we usually do this by just having an ad blocker as an extension in your browser, and the ad blocker can pull down lists of known malicious websites, and then when the user clicks on that phishing link, the ad blocker's filter list prevents the browser from opening that link. Then you just got to make sure the user's not using a different browser that doesn't have the extension installed. Speaking of extensions, a lot of extensions that are out there in the world are malicious. They're doing bad things, just like adware and spyware as an application. There's adware, spyware, browser extensions that we find in environments all the time. You'll want to lock down the extensions that you're going to find inside of primarily browsers, but most email clients as well, to make sure they're not running something that shouldn't be there. When it comes to malware defenses, Linux does have malware that we do run across pretty regularly. If you've got a commercial AV product or an EDR product, have that installed in your environment. If you can't, for whatever reason, run some kind of a big enterprise product that gives you a central dashboard, run a local client that's going to log locally when it finds an AV detection. But now, as the central security guy, I don't know about the detections happening in your workstation. So make sure those logs are getting pulled off, added to the syslog stream, and pushed up to me somehow. And then I'll be able to at least find out that the local isolated version of AV on your workstation is detecting something. If you can, use application allow listing. I did an incident response a while back, and we found that victim was halfway through installing an application allow listing project, and guess where we found all the malware? Literally 50% of the workstations had it, and the other 50% that had already had allow listing installed didn't catch the malware. It's one of the best defenses you can have out there, but it creates a significant management burden to keep it up and running, but it can be done. Right? And file integrity monitoring. It's monitoring, it's not prevention, but at least it tells you about the modifications to the files, so I can get an alert in the central dashboard that's monitoring this. There's commercial FIM tools, or if you grab something like OSSec, OS Query, they have a FIM component to their agent that's installed on that workstation, and you can get it through Audit D. Audit D will do the logging, but then you still have to build some kind of a dashboard to an alert system for telling you if files you care about have been modified. And most of the anti-exploitation features of the kernel are on by default in AlmaLinux, but you do want to go through and make sure that they weren't turned off for some reason, and there's a few of them that require a little extra tuning after they're on. Backups are incredibly important. If you get ransomware in your environment and it starts encrypting files, the best solution for that is to just get the malware off the workstation and restore the data that was encrypted from the backups. But that only works if you have backups. So very, very important that you take backups, you keep the backups off-site somewhere, you periodically test your backup process. I've run across multiple cybercrime groups that will get into an environment and sit around for days, weeks, sometimes even multiple months, and they will find and target your backup server quietly in the background, corrupting backups for 4 or 5 weeks, and then they'll launch the ransomware and start encrypting files. That way, when you go to try and restore from backups, your backups are all corrupted and you can't, and you're more likely to pay the ransom. So very, very important that you catch the bad guy on your network before they mess up your backups. You create backups that are immutable, that they can't corrupt, and then just don't get malware. Right? If you can, it's also really important to sync to the cloud. That gives you that offsite backup, and a lot of times what you're syncing to can have snapshots and immutable storage so that they can't be corrupted. Now, most of your popular cloud storage systems don't have a Linux client. So Box, OneDrive, there's not a native client from them that is stable. Dropbox does have one, but it's not as featureful as the Windows and Mac version of the Dropbox client. One way you can get around that is to, while they're inside the building, or if you have a always-on VPN, you can be using rsync to push to a file server and then do the cloud sync from the file server up. And now they've got a copy on their workstation, they've got a copy on the file server in your environment and a copy up in whatever you sync to, Box or AWS, whatever it is. Another way you can get around it is rclone. rclone has an agent you can install on a workstation that can connect to a bunch of the cloud providers, and it can step in where Box and OneDrive failed to provide a client and be that endpoint client. So if you've already got Google Drive or Office 365 for all of your users, you can put the rclone client on and have it syncing up to whatever that cloud storage is that's tied to their account. Now their desktop folder, their documents folder is synced to the cloud. If they lose that laptop, they can immediately get their data back. Network monitoring. When we read these controls down here in this bottom corner, most of those controls are really focusing on the network, but there's some things you can do to the individual endpoint to help that process along a little bit. When you read the controls, they're talking about a firewall. They're almost always talking about the network appliance that's at the perimeter of some trust zone on your environment. Take the concepts, read between the lines, and figure out what the intent of the sentence was, and then apply that to the host-based firewall that's on each individual workstation. When a user folds a laptop down and takes it home, they open up a VPN connection. Now they've got an internet connection at home and a VPN connection into your environment. They just became a second ISP for your environment. So very, very important that you're doing the same kind of filtering there to keep bad guys from using that tunnel into your environment. One of the ways you can set up your host-based firewall to be a little more helpful is to use tools like Fail4Ban and CrowdSec. CrowdSec especially, it can download lists, much like the way an ad blocker downloads list of here's the known malware servers that you should filter from your browser. What CrowdSec will do is download similar lists and then automatically update your local host-based firewall with block rules. Now when your user clicks on a phishing link and tries to go to evil.com in their browser, or if there's a background bit of malware that's trying to go to a command and control server somewhere, CrowdSec will block that traffic using your local host firewall. Right. You can also put on a host-based IDS. That way, while that user's working from a coffee shop somewhere, the security team can still be receiving alerts if they're going to any bad websites. If you've got a commercial EDR tool, use it. If you don't, AID and OSSec can give you a host-based IDS on your workstations, and then you can just have the telemetry stream up to a cloud somewhere. You just make it internet-facing so that it can receive data from those remote workstations, and then you can remotely monitor those workstations from anywhere in the world. If you can, collect network traffic flow logs. You don't have to grab full content. If you're trying to grab full content every time the user's watching cat videos, it's going to fill up with gigs of data. You don't want that. But if they watch a cat video and I store a single log entry that says they went to this IP address and downloaded this much data, that is an amazing helpful to me. If a user clicks on a phishing or receives a phishing email, I'm looking at the link in that email. One of the questions I'm going to have is, who in my environment clicked the link? And I can go to this network telemetry and answer that question. So if I see indicators on one workstation that this is what the malware looks like, I can then use this telemetry to look at every other workstation and figure out who else has that malware that's not setting off alarms for whatever reason. And same way we want to do encryption at rest, we also have to do encryption in transit. VPN links are your friends here. If you're using something like just regular IPsec tunnels and OpenSec VPN, that's great. If you're moving to a more modern ZTNA setup, that's even better. But you should have some kind of encryption on those workstations. If your users are taking their laptops out to coffee shops, you want to have that local last mile encrypted for all of their traffic. That way somebody else sitting in that coffee shop isn't like sniffing internet traffic and figuring out what they're doing. If you're even inside your data center, if it's a really sensitive workflow carrying very sensitive data, you should still be doing encryption in transit between server and client inside your own environment. If an attacker does get into your network and starts sniffing traffic, you don't want them picking up sensitive files back and forth as they transit the network. There's a group goes by the name of Fin7, or more colloquially Carbonac, who used to do this to banks with great regularity. They would break into a bank and they would sit and monitor network traffic, and they would do a man-in-the-middle attack between a server and the FTP proxy and the DMZ. And when a transaction file would go by, they would capture it, modify it, and then send it on in. And they were injecting transactions in that the bank couldn't see. Very, very bad. You don't want that to happen in your environments. AppSec, most of the AppSec talk is about you building security into applications you're developing. It's also about having an inventory of what you're installed on your workstations. So build up a software bill of materials, keep track of what those various libraries are. Then when somebody comes to you and says, are we running Log4j anywhere in our environment, you can actually answer that question. Right? If every one of the applications you've got out there probably publishes some kind of a security guide for how do you properly lock Apache or PHP or whatever down. Follow it if you've got it. Some of them don't have them, so you just kind of have to fake it. If you're doing any kind of in-house developed apps, make sure that those developers are following secure coding practices, secure by design principles, and scripts that you're using to do automation across your entire environment, that's software that you just developed in-house. So apply all those same principles to your own Ansible scripts, or even just bash scripts that are doing bulk edits to your entire render farm. Treat those same secure by design principles to that scripting that you use for your own remote administration, and that'll bring principles in, such as not having passwords hard-coded into scripts and coming up with other ways to do authentication. That way, if a bad guy gets on that box and starts reading your scripts, they don't steal credentials to stuff. And then incident response. If very, very important, when you do have an incident that kicks off, we're going to have to go do analysis on those workstations in order to figure out what was the bad guy that got onto this box. How did they get in? Did they steal a user's password and log in as the user, or did they have some other kind of backdoor get installed surreptitiously? We got to answer all those questions. And as an admin trying to assist the incident responder, it's worth your while to go sit through an IR class and learn how the forensics and incident response process works. That way, when you go to assist, you don't accidentally step on and destroy evidence. You can actually handle that evidence correctly so that it helps. If the case does decide that we figured out who this bad guy was and we want to actually call the FBI and get him prosecuted, we need the evidence we collected to be able to stand up in court. So if you know those concepts ahead of time, you can be much more of a value add instead of accidentally stepping on data and hurting it. So very, very important. Your incident response team, if you've got a company big enough to have one, is going to have gone through that training. If you've got an IR retainer with a big company, they've gone through that training. You guys should go through that training, not because you plan on doing the IRs yourselves, but that way when that expert does show up and say, I need help, you can better help them. Right. And if you've got an EDR tool available to you, highly, highly, highly recommend it. If we decide there's ransomware on your network and I need to lock down these 400 machines right now before the infected list gets to 500 to 600, then we need a way to be able to move very, very quickly and get ahead of that malware, and you're going to need an EDR tool to do that. If you've got a commercial EDR tool, great. I love your budget. If you don't have a commercial EDR tool, there are tools out there like GUR Velociraptor that you can deploy that are free open source. You just got to do a little bit of extra work to set them up. OSUC, Waza, OSQuery are not full EDR tools, but they at least collect the telemetry and will assist in doing rapid searches across your environment. And what we're looking for is a single button way to quarantine workstations and kill processes and delete files. So if I have to SSH into a box and run 4 or 5 commands to do that, it's going to slow down the response. So having that EDR tool allows me to queue those commands up and say, send that command to these 400 workstations and hit it once and have it all go out. All right? So when it comes to hardening those workstations, some places you can go. The CIS benchmarks are great. The DISA publishes something called a STIG. The STIGs are a pain in the ass to read. The first link is to the actual DISA STIG. The second link down is a stigviewer.com. STIGs aren't designed to be read. They're designed to be opened up in a tool. So what you'll download from DISA is actually an XML file that's unreadable. But if you go to something like StigViewer, they've pulled out what are all the changes that the STIG will suggest, and then you can actually see, cherry pick out the ones that apply to your environment and start making those changes to your environments. OpenSCAP is the same concept as the STIG program, but it's an open standard that's international instead of being a US government thing. So I highly recommend skip through the OpenSCAP guide for your devices as you're building up your gold disk images, and that'll give you an idea what to look for. And with that, I am way over time, and I am in between you and lunch. So I'll answer questions at lunch. Otherwise, off to you.